this is a promo video of SPT online classes, and I'm going to show you some small basic concepts of AC. There are so many students having a lot of doubts regarding the power calculation of AC. So let me make it very clear right now. After seeing this video, it should be very clear for you that how the term power works. Okay, so we know that in DC power is equal to voltage into current. Okay, voltage into current, or we can write it as V square by R or I square R. All these are power terms. Remember, power is a scalar quantity, whatever. Once it comes to AC, okay, this is the case of a DC circuit. Once it comes to AC circuit, then the formula for the power, it becomes Vrms I RMS cos phi. This is the average power equation that we normally substitute for AC circuit. So what is the reason for substituting Vrms I RMS cos phi? Why we are not taking Vrms I RMS sin phi? Why not Vi cos phi? Why not Vi sin phi? So many questions will be coming. The first thing you have to understand is that AC is alternating and DC is constant. In that case, when AC becomes alternating, if you simply take the average voltage of a cycle, we know that the average voltage is zero. So there is no logic in taking simple VI term, because what you can see is that if you, in the case of DC, we know that in the case of DC the voltage is constant, correct? With respect to time, the voltage is constant, but in the case of AC, voltage is varying with respect to time. So at every single instant, the voltage of DC, you are getting a constant value C, but in the case of AC, it's keep on varying. So if you simply write VI, that will be the instantaneous power. We don't have much use with it. We need at least power. When we calculate power, we need at least a few cycles, the power of few cycles. So we have to take the concept of RMS, and that's exactly why we are taking the concept of root mean square. Okay, now that's fine. So now we understood why we are taking RMS instead of simple VI. If you take simple VI, then it becomes instantaneous power. So we are taking RMS. Now comes the question, why it is cos phi? Okay, why it is cos phi? Why it is not sin phi? For that, you should know the idea about Vrms IRMS cos phi, the entire average power term itself. This is the first thing you should have an idea, average power. Okay, this actually comes from the term apparent power. Now apparent power is equal to root of, okay, this average power. Let me write it like P plus square plus reactive power square. Now average power is also called as active power. Okay, it's also called as true power. So there are different terms for this average power or active power and true power, and reactive power is what we call as Vrms IRMS sin phi term. I'll explain what is the meaning of all this, but just be patient. So we know that active power or average power or true power is Vrms IRMS cos phi. Let's substitute that value. Vrms IRMS cos phi square plus Vrms IRMS sin phi square, okay, whole square. What you are going to get is sin square theta plus cos square theta equal to 1. Then root of Vrms square IRMS square will give you the result, which will be equal to Vrms IRMS. So Vrms IRMS is our apparent power. Now, why we need three powers? Why we can't stick upon to one single power? So that is what the logic is. Now listen, imagine we have two region, so two places. And imagine you are standing over here. Okay, let me put some hair for you. Great. Now I'm standing over here. Okay, and you are sending me some power through transmission line. Fine. So the fundamental concept is that if you want to transmit the power from A to B, then these three powers, okay, apparent power, active power, and reactive power are coming into action. So if you want to send the power from A to B, what you're sending is apparent power. Apparent power is what you send. Now where is active and reactive coming into play? Reactive power is the power that is used to magnetize this entire transmission line. Okay, reactive power is that which is used to magnetize the entire transmission line, and active power is the useful power which is being sent through this magnetized line. So simply you cannot send active power. This is a concept. If you want to send some active power, you need some reactive power, and there is no use we cannot use reactive power directly. We can use active power only, which means in a home, if there is a bulb and if this bulb wants to glow, imagine if this bulb wants to glow, that is called the useful power, which is also called as the active power. So we need active power, but to get the active power, you have to send apparent power. Apparent power consists of active and reactive. So what will reactive do? Reactive power first will magnetize the entire transmission line. Through that, the active power will be coming to my home, and it will make the bulb glow. And what will happen to reactive power? It will just vanish out or what, or it will dissipate or what? It won't get dissipated. We are not using it, but we are actually using the help of reactive power, but we are not dissipating it, we are not wasting it, we are not taking that reactive power into back to environment. We are sending that back to the power station itself. So, and that's exactly why we are in our home, if you have an energy meter, that energy meter will work only if you are using active power and not reactive power. It's a very fundamental concept. So person A is sending apparent power to person B, which includes active and reactive. Reactive is used to magnetize the wire. After that, it will go back, and active power is the power which is used to send through the reactive power to make your bulbs glow. So then comes the question. Reactive power is used to magnetize. Fine, great. So what about if you have a fan? What about if you have a motor, in self-induction motor, which is used to pump water from the pond or pool to your water tank, which is kept at above? How it works then? So all these things will contain coil, induction coil. Okay, all these work based on electromagnetic induction. And in order for this fan and motor to work, this induction coil should be magnetized, and for that you need reactive power. But remember, even though you need reactive power, it's not getting wasted, it's not getting dissipated. What it will only do is that the fan will use the reactive power to magnetize your coil. That's it. Which means if you turn on your fan, and if the coil inside your fan is 100% ideal, okay, 100% ideal, then your fan is not using any electricity. Why? Because the reactive power will magnetize your coil and it will go back, and we are not using that reactive power. But if you are having a light, and if you are turning on that light, definitely that light will be using the active power, and it will glow, and it will dissipate the energy, dissipate the electrical energy to light and heat. So that's the difference. So technically you are not using any kind of reactive power, you are just using the active power. At the same time, you need the help of reactive power to magnetize the coil, and after that you are giving it back to the power generation unit. Okay, so if next time your parents are telling you to switch off the fan, and you can say that mommy or daddy, this fan is having an induction motor, and induction motor works based on the electromagnetic induction principle, and if the coil is ideal, then you are not wasting heat. But your mom or dad, they are not fools, they know that Nothing is ideal. When nothing is ideal, your fan or your motor will be having, that coil will be having some resistance, and that resistance will dissipate heat. So that's the concept of this active and reactive power. Or let me make it very simple for you by drawing the uh, say some lace packet. Drawing the figure of lace packet, we know that lace, okay, lace consists of some chips, okay, some chips which we need it for eating, and the remaining is gas. Which gas? Nitrogen gas. So the question is, why can't they sell without nitrogen gas? The reason is simple, because nitrogen gas will help the packet, will help the chips to be kept in an undecayed position. Okay, if it is oxygen or carbon dioxide, it gets decayed, and that's why we fill it with nitrogen. Got it? So we need the help of nitrogen gas, but we are not using it. The moment you open the packet, the nitrogen will go. So the question is, the chips inside this packet, the chips inside the packet, we can call it as active power. We can call it active power because that's the power which you are going to use, and the nitrogen gas is our reactive power. Got it? And the entire packet, what will you call? The entire packet means the apparent power, because apparent power is equal to root of reactive power square plus active power square. And what is reactive power? Reactive power, let me take that concept back. Reactive power is equal to Vrms Irms sine phi. Vrms Irms sine phi, and it all comes from the power triangle or the impedance triangle. So let me draw the impedance triangle first. This is phi, and this is z, this is r, this is x. So what is cos phi? Cos phi equal to adjacent side by hypotenuse, so r by z. What is sin phi? Sin phi equal to opposite side by hypotenuse, which is x by z. This is called as impedance triangle. Impedance triangle. And if I draw a power triangle also, power triangle, then similar to this, you can draw a power triangle just like that, and we have phi over here, we have apparent power over here, apparent power, we have reactive power over here, reactive power, and we have active power over here. So let me use the cos phi formula. Cos phi is equal to active power by apparent power. Cos phi is equal to active power by apparent power, and we know apparent power is Vrms Irms. So what is active power? Active power becomes apparent power into cos phi, that is Vrms Irms into cos phi. Similarly, you can write for sin phi, which will be equal to, okay, sin phi will be equal to reactive power divided by apparent power, reactive power divided by apparent power, and thus you get the reactive power equation as Vrms Irms sin phi. Vrms Irms sin phi. That's how you get the power terms. And remember, we call cos phi as the power factor. We call the cos phi as a power factor, and this value will be varying from -1 to 1. And if it is more towards the unity, if it should be more towards unity while you are sending power or purchasing power. So that's why whenever you purchase power from some company, or if you are selling it, you have to make sure that the power factor is close towards unity or 1. Okay, so that is a concept of the power in AC. Hope you understood what I told just now. This is the entire power concept, what you should learn in depth to get a clearer picture about the AC. Okay, thank you.